Okay, everybody. So if you are missing any of the example, you could certainly get it off GitHub. The last thing we were looking at yesterday was the incorporation of this new class called the meeting class and how that worked. So I want to just quickly look at that, and then we're going to move to our next topic. So real quick on topics here. This now allows me to check off what we looked at yesterday, which was this thing called the instance of operator. So I'm going to put that here and here. We also talked about the concept of polymorphism. So I'm going to put a check mark there. So in our vocabulary list, there's only a few words left for this unit. They happen to be big words though. There are also the concepts over here of abstraction, using an interface, and using these things called generics. So they're the last three big topics and three words to learn in this unit. It's been a big unit, okay? So actually, let's just take a second here. To help understand classes, a diagram I've been drawing has used a format called a Universal Modeling Language Diagram, or UML. It's very commonly used by professional programmers. There's certainly an advanced way to look at this. That's this thing over here. This is the advanced look at what this is, where you lay out the properties and the methods, and you have a certain style to it. But we've been using more of this simple format, where we just use the name of our class inside of a box. And I just noticed Avery logging in. So I'm going to just quickly pause for a second and change attendance. There we go. Okay. So that would be the simple format right there. So if we put that together with also a couple of different styles of arrows to show how one class can connect to another class. So the way I drew it in the diagram is if I drew a straight arrow with a filled in arrowhead, that meant that there was inheritance taking place, or the is-a relationship, okay? If I drew a dotted line with a hollow or an unfilled arrowhead, that meant it was a has-a relationship. In other words, one class was just using another class, or it was built from or associated or composed of another class. Okay, so when we take a look at the first three classes we made, the person class, the student class, and the book class. The person class was on its own, and then the student class inherited from the person class. It is a student person. Sorry, a student is a person. Okay, so the person class is the parent class, the student class is the child class. Within the student class, we created a reference to a book object, the book class. So it wasn't inheritance, it's just that the student has a book. In other words, our student class was associated with the book class, or the student class is composed of the book class. Now we got bigger. We then added a teacher class, and we realized that our testing class, the advanced classes test, was using the person class, using the student class, even using the teacher class. So then we incorporated the other classes we worked on in our previous units, like the recursion test and the tester class and the calculator, etc. And so we were able to draw a diagram all together, and we also were taught, or I taught you, that all classes inherit from the object class, including classes that we use all the time without writing them, like J-option pane and system and string and math. These are classes we just use with our Java code, but everything comes from or is a object. So that was where we were. Okay. And then in this last week or so, I've said, well, let's bring in some more classes. Let's bring in the doctor class, the baker class, the piper, the husky, the high school, the Mr. Walks class. All of these classes were brought in as well. And then as of yesterday, we also brought in the meeting class. Now, the meeting class uses the person class, but because the person class is the parent of so many classes, it uses polymorphism to do what we did yesterday, which was in our meeting class, write a complicated method like our hold method, which loops through an array of person objects and uses a new thing called instance of to look at the child versus the parent and kind of how all that vocabulary comes together. So now here studying classes, we're definitely moving to a more advanced topic level. Okay, So that's where we're at. That's where we're at in terms of the classes unit. Just going to jump back to that vocabulary list again for a second. So there's all those things. Now, there were other things we learned in this unit, things like what an accessor and a mutator was, the toString, the clone, the equals, what protected means. We learned about the enhanced for loop. We learned about static. We reviewed things like encapsulation and inheritance and properties and methods and a lot of the vocabulary that went with all that. It's been a huge unit and it continues now. Okay, but what I want to introduce to you guys today is the concept of an abstract class and something called an abstract method. Okay, so we're going to incorporate those into our example, but let me first explain essentially what they are. So just the word abstraction is a concept of dealing with ideas, right? Like abstract art is art that doesn't necessarily look like what it's supposed to. Like if you're drawing abstract art of your friend, it won't necessarily look like your friend. It deals with what the idea of your friend is. So abstraction in general is dealing with ideas, not with specifics. So in programming, abstraction is achieved by using abstract classes and abstract interfaces, which we'll get to as well, and abstract methods. So with abstraction, the concept, it lets you focus on what the object does, not how it does it. And this is really important when you're building complex programs, even games. That might be how you plan out a game. You plan out, okay, this is what the game is going to do. Don't worry too much about how it's going to do it, just what it's going to do. And then when you get down to the specifics of the game, you're like, okay, well, this is going to be a character in my game, and this is what the character is going to do. So thinking that way, thinking abstractly, lets you kind of get into a planning mode without worrying about the details of how it does it. So a specific thing about abstract classes cannot be instantiated. In other words, it's a class that cannot be used to create an object. Now, I mention this because I want to go back to this portion of our diagram. Here's our diagram as it currently is, and all the classes that we have. Is there a class here that you see is not used by any of the other classes? Okay, and I mean, don't look at the ones from the previous units, right? Don't look at ones like math and system and all that. Okay, so for example, if I trace from, oops, that wasn't what I wanted to do. Put one on there. There we go. If I trace from the testing class, which classes does advanced classes test use? And I trace this dotted line, I'd be like, oh yeah, it uses the meeting class. Let's see, what else does it use? Well, it uses the person class. Okay. Now I'm thinking, well, it doesn't use the book class, so maybe that's the class he's talking about. Then I go down, it uses the student class. Oh, wait a minute, the student class uses the book class. So there it is. Then I go further down, it uses Husky, it uses Piper, it uses Mr. Walks, it uses teacher, it uses doctor, it uses baker. There is one class right here that it doesn't use. It doesn't use the high school class. It doesn't use it ever. Okay, now I realize that a Husky is a high school, so in a way it kind of uses it. So by using the Husky, it's essentially using high school, kind of like how it used book. But I think the simpler way would be how many dotted line hollow arrows are pointing to objects on this diagram. And if I follow all these dotted line hollow arrows to all the classes that they point to, right? In other words, all the classes that are being used. Actually, let me redraw that. So I'll just start here. This one, this one, this one, this one. Again, just focusing on those dotted line arrows. Don't worry about inheritance right now. Just think about the meeting class, right? And even if I went into other units, like, oh, the calculator is being used, recursion test is being used, Advanced classes test is being used, even testers being used. So the only other one would be computer science 40S. The only other class other than high school that isn't got an arrow pointing into it that has a dotted line. They're the only two. And yes, I realize these ones as well, but we didn't write these classes. So I want to focus on this high school class. A high school class would qualify as an abstract class. It's a class that I never make an object with it. I never say high school equals new high school. I never do that, okay? So what's the purpose of making a class abstract? Because if you make it abstract, it can never be turned into an object. Well, the purpose of this is to act as a parent class, which is what high school does. It's the parent of Husky and it's the parent of Piper. So it acts as a base class for all subclasses, knowing it's never going to be instantiated, okay? So here's what I want to do. I want to go back to our class called high school. We really didn't do much with it. It really has nothing to it. So open up the high school class. Okay. And as you can see, student, that was really the only thing we added. And we just changed up the constructor. But what I'm also going to do is I'm going to slip a modifier word in between public class, and that modifier word is abstract. An abstract class here. And I'm going to add this as a comment here. Abstract is a class which can, oh, sorry guys, typing is a little off today, which can not ever be instantiated. Okay? So that's the first thing I'm going to say about that. And I'm going to test that by putting it into our testing class. I'm going to intentionally force an error here. Abstract classes cannot ever be instantiated. For example, if I tried to go and make high school okay, which I just imported, high school equals new high school, give it a name, age, and student. Notice it's doing something weird with the code. It is generating an error, and that error is clear. High school is abstract. It cannot be instantiated. So this line is impossible. So I'm going to comment it out. It's an error, okay? That high school class is now made abstract, okay? So by making it abstract, this is now code that cannot be done. If I took that out of there, then this would be no longer a problem. Give it a second, and now it's not a problem anymore, okay? So it's having that keyword in there that makes a difference. But why would I do this? Why would I ever do this, right? This means this class can only act as a parent class for other child classes, which in this case are Husky and Piper. Those are the classes that come from or are children of high school, okay? So I'm adding that into high school as an example, but we're gonna make another class like this, another abstract class. We're actually gonna make a couple different abstract classes. Okay, so no questions at this point. Speaker check. Speaker's good. Okay, so now what I want you guys to do is inside of our testing.advanced classes package, I want you to right click, create a new Java class. It's still going to be a class, but it's going to incorporate the concept of abstraction. It's going to be an abstract object and the way you should think about abstract classes is they, again, represent ideas, not specifics. The class type we're going to create is food with a it's still a class, so you're going to use a capital F for food, and hit finish. Okay, and there's their food class. We won't need toString equals and clone, so if you want, you can delete those, but keep the constructor. The constructor is still important. So with your food class, keep the constructor, but you don't need toString equals and clone if they came from your template. We'll rewrite the constructor in a minute, so let's not worry too much about that. But I want you to add the keyword abstract to this class, okay? So food is also an abstract class, okay? We're going to incorporate it into our diagram in a minute, okay? But this is an important thing, right? Like, what is this idea of an abstract class? Well, it can't be instantiated, okay? And as I said in the last point of this slide right here in our notes, that to create an abstract class, add the abstract modifier, which we did. But it also says that now that you've made an abstract class, you can now create abstract methods. Prior to that, you couldn't do that, okay? You couldn't add abstract methods to a regular class. Okay, now what does an abstract method mean? Well, an abstract method is just a method that also includes the keyword abstract. So for example, don't do this in your example, but back here in high school, because it's abstract, I could do this. But in our meeting class, which is not an abstract class, it's a regular class. If I tried to add the word abstract here as part of our meeting method, our method called attend, if I tried to add that modifier word to here, it would give me the error. Abstract methods can't be done this way. Well, it's a little more specific to it, but there's an error with doing this. You can't make an abstract method within a regular class, but within an abstract class, you can do this, okay? So we're going to create a method. It's going to be public. It's going to be abstract, okay? And it's going to be a void method. It's going to be simple. And we're just going to make a method that is about how you prepare this food. Method that is now initially you get this error right here and you're like, okay, I'm going to make the method, but that would actually cause an error as well. So I'm going to just back up here for a second. The other interesting thing about abstract classes and abstract methods is abstract methods have no content to them, because something that's abstract is just an idea. It doesn't tell you specifically how to do it. So believe it or not, with abstract methods, you just put a semicolon right there. And that's what an abstract method looks like, which is weird. Okay, so the idea of abstraction is going to be a bizarre one. You're going to later kind of realize why you do this, but for now I'm just showing you how you do this. So I can make an abstract method inside of an abstract class, but it has no body to it. So let me put a comment about that in a second. But I do have a slide that also explains this to you guys. So let me bring this up. You declare a method as abstract by adding that abstract keyword in the method. The abstract method has no code, no implementation. It's just the method signature that ends with a semicolon, no curly brackets. And the rule is, if you add the keyword abstract, making a method abstract, then the class must be an abstract class. Okay, there's a little more to it than that, but let's just sort of put some of that into the comment here on this abstract method called prepare. And then we'll be kind of ready to be kind of done for the day. Okay. So first of all, what is this method prepare? Okay. So the method prepare, okay, it prepares food to be eaten. That's what it does. Okay. But let's add a little more to this to explain what's going on in our notes, so to speak. By adding the modifier abstract to a method, it makes it an abstract method. Means method has no code for the body. And I'm just going to put in brackets also, no curly brackets. Okay. And ends in a semicolon. That's something we know about abstract methods. That's how they work. Okay. So the method prepare will be preparing food to be eaten. By adding the keyword abstract, it makes it an abstract method, which means the method has no code for the body and ends in a semicolon. Note, it can have parameters. And it can return a value. It doesn't in this case, but it can do that, right? And actually, we'll do a version of a abstract method that kind of does that as well, okay? But now the other important point of kind of the rule here is, and I think I'm going to put this up in the description of our food class, right? So the description of the food class and what's going on here. I'm going to cheat a little bit and put the comment in as a copy paste here, but this will go up on GitHub. This is an abstract class representing the concept, and I'm going to put that in single quotes here so it stands out. Concept of food. Abstract classes can never be instantiated. No objects can be created, but they can act as a parent class to children classes. Once a class has been made abstract, then you can add abstract methods to the class. And you can also add regular methods. Abstract methods cannot be added to regular classes. Okay, so we've already talked about that as essentially as a rule here. Okay, so that's an abstract class called prepare. Okay, let's do another one, another abstract class, or sorry, another abstract method, public. But this one will return a Boolean. And it'll just be, can I eat this food? Yes or no, true or false. You know what, all food by definition can be eaten. So that maybe that's not the right, let's think of something else. Can this food be, can it be stored? Stored. Some food can be stored for a long time, like a can of soup, but a banana can't really be stored, okay? Or how about, has this food spoiled? How about that? Has it spoiled, yes or no? That's a good abstract method. Okay, now let's do an abstract method that has a parameter, something that we would give to the food. Public, abstract, we're almost done. We'll make it a void method. So one thing we would give our food is let's think. You guys feel free to speak up on the microphone here. Let's think of an abstract concept, something you would give to food in general. You'd give it a, a uh, smell our food for this many minutes or this many seconds, right? So some food you'd want to smell for a long time. So that's going to be an abstract method that requires us to give it how many seconds to smell that food, okay? So you can see that abstract methods can return stuff and they can take parameters or both, or they can be void methods with no parameters. The point is, we are going to explore what these things called abstract methods are and how they relate to abstract classes. That's where we're going forward with this, right? That's what we're going to be doing, okay? All right, but that's where I'm going to stop with you guys for today. It's 11:32. I think that's a good stopping point for you guys. This class has been recorded, so I will connect that in. Tomorrow, we will continue our look at abstract classes. And actually, let me just show you real quick what we're going to be doing. Not only are we going to be doing food, but we're going to make two food objects, apple and steak, okay? And they will also be abstract. Or will they? We'll look at that tomorrow. So as you can see up here, my little note, abstract classes cannot be instantiated. For UML diagrams, by the way, the only difference between an abstract class, the way it looks, and a regular class is that they write the name of the class in italics. Okay? So that's why over here I wrote high school in italics. Okay? So that's what we're going to do for tomorrow. We're going to finish up the food class. We're going to create some children of the food class, and then we will sort of incorporate it into our example. But that's it for today, guys. You can, there it is. You can log off for today if you guys like, and I'll see you guys for attendance tomorrow. The remainder of the period here is open time for help for both you guys in 40S and for the 30S students as well. Also, help available at 3 o'clock today if you need it. Have a great day, everybody.